Hi guys, today this is going to be our first video on Unit 7, and this unit is going to be very similar to the derivative unit of y, where we're taking derivatives of y with respect to x. So now we're going to start with, this is just kind of like the introduction, but it still appears like it'll be 2% of the questions. So first question will be y equals e to the negative 4x, and the equation that we are checking is going to be y prime plus 3y prime equals 4y. Now, this might look complex at first, but it's really not that hard. It's just this one, take the derivative twice of that, minus take 3 times the first derivative, minus what we already have. So to start this, we're just going to take the first derivative of this, which is going to be negative 4 e to the negative 4x. So how did I get this? Because e to the x, it's our basic derivative, where you're just moving it to the front, and e to the x is just e to the x, chain rule. And then y double prime, you'll do the same exact thing. Negative 4 times negative 4 is just 16e to the negative 4x. Okay, so now that we have our equations, we just plug them in. So 16e to the negative 4x minus 3 times this is going to be negative 12. Negative 12 e to the negative 4x equals 4 e to the negative 4x. Okay, so now what do we get? 16 minus 12 is just going to be 4 e to the negative 4x equals 4 e to the negative 4x. This means this is true. Okay, now let's look at another problem which they might give you, which involves k and solving, but it's the same basic premise. So for this, you're going to say we have 3x squared plus 2y squared equals c, and you are trying to prove that 3x plus 2y y prime equals 0. So c is not of value to us. It's basically just saying that it equals the constant. So now we need to get y by itself so we can solve for that and then go from there. So to do this, we're just going to do y over, so 3x, negative 3x squared plus c equals 2y squared. Divide this by 2, square root it. So, and c is just a constant, so it's left as c. So we have the square root of negative 3x squared over 2 plus c equals y. Now we don't really need c in this equation, so we can just get rid of it. Okay, so now we take the derivative of y prime, and then we can solve from there. So the derivative of y prime is going to be, so this is 1/2 times that. We're going to need to chain rule this. So you have negative 3 over 2 times x squared all to the power of 1/2. So you're going to put it in front, 1/2 times negative 3 over 2x squared times x squared, put it forward, negative 3x. Okay, we're going to add them together, and that will end up giving us, okay, we'll get 9x, so 3x times 3x squared would be 9x cubed over 2 over 2. This 2 is going to go to the top, so you have 18x cubed over 2, which ends up giving us 9x cubed. Okay, so that is equal to our y prime. Now we go back to this equation, and we'll plug it in what we have. So 3x plus 2, the y value we solved for before was 3x squared, or sorry, was the square root of negative 3x squared over 2. This 2's cancel out, and then our y prime was 9x cubed. So now we have 3x plus 9x cubed times that will end up giving us this squared will cancel out because we canceled out our 2's, and we'll be left with negative 27x to the 4th. And now the only way this equals 0 is when x equals 0, but we can also take out a 3, and that's just still going to give us x minus 9x cubed. But basically, all you're going to do is, for all these equations, you're just going to find your y, take y prime, and plug it into the equations. Okay, now we're going to do a little bit of a different problem. So we're going to solve for k. That will, if any, that will be a solution to this one. So our y that is given is k sine 5x plus 2 cosine 4x. Okay, and then the equation that we're checking for is y double prime plus 16y equals negative 27 sine 5x. Okay, so this is not going to get touched. We're just going to check for this and then plug the k value and that will work for it. Okay, so let's start this by taking the first derivative, which is going to be 5k cosine 5x. This is just the chain rule. You take the derivative of this, then the inside, plus, or I should say minus, because it's going to become negative 8 sine 4x. Then we're going to take the second derivative, which will do this again. It's going to become negative 25 sine 5x minus, see, 4 times 8, 32 cosine 4x. Okay, so now we have both our derivatives. So the double derivative will take this plus 16 times our original y, which was k, I forgot the k over here, k sine 5x plus 2 cosine 4x. Okay, and now we'll distribute the 16 out. Okay, and 16 plus that, minus, so 25 plus 16, negative 25 plus 16 is going to give us 9k sine 5x, negative because this is the bigger number. And then 16 times 2 is going to be 32. These are going to cancel out, luckily. And then we're going to set this equal all the way up here. Okay, negative 27 sine 5x. And hopefully you can see where this is going. These two will cancel out. And we're just trying to find where negative 9k equals negative 27. Divide by negative 9. K equals 3. So 3 is our solution to this, where we're looking for k. This is, all of these equations are basically set up for you to guess and check and plug in from there. All you need to know is the derivatives. And generally, you're just going to go as far as you see the derivatives go, and you will be fine. It's just plug and chug from there. Okay, one last thing I want to add is slope fields. So for slope fields, these aren't hard. It's just you plug in for the slope and then you graph it for each individual point. So for the basic one I'm going to give you is dy over dx. This is slope, remember, equals x plus 1. So for this one, we're going to imagine this is our x, this is our y, okay? So now x plus 1, that's just going to mean for every single time this increases, the slope will increase. So this will be 1, and you're just going to, for all these y's, you're just going to make it that x slope. Okay, and then plus 1, again, is going to be a little bit greater, and then a little bit greater. Now, -1 plus 1 is going to be 0, so you're going to get the zeros. And then you're going to start getting negatives. Now, it's a little bit more advanced to like look and tell, but from this you can kind of see what the pattern emerging is that it's going down, getting flat, and then coming back up more extreme. And what does that kind of look like? An exponential function. And we know this because when we took derivatives, the slope of the actual function, so if it was an exponential function, the slope would look like a linear function because it just goes down. So this can kind of tell us what our original function looked like. Okay, now let's look at one that's going to be probably the most advanced slope field you're going to see. It's never going to be an advanced slope field or that hard. So dy over dx will equal -y over x. This may look a little challenging, but it's really just you're plugging in the y value and the x value. So at 0, 0, it's going to be, that's one thing you need to watch out for is anything with division is it's going to be indeterminate for when it's 0. So when x is equal to 0, you're just not going to be able to graph this, so you just leave it blank. Okay, and then for this one, x is 1, y is 0. So for all of these are going to be flat because y is equal to 0 on top. Okay, and now -y, so -1 over 1 is going to be -1. Then you have -2 over that, so it's going to be a more increase. This is just going to be the inverse of that side. And now you're going to have it divided by 2, so this is going to be half, -1, half, -1. And then it's going to basically just look like a more extreme version of the same thing on the other side, coming from the other direction. And generally, the more you do these, the more you'll kind of have a general feel for what it looks like. But most of the time, they're inflected or similar in some way, and graphing them is pretty easy. And if you're just in doubt, you can plug and chug. Okay, the last thing involving slope fields that might come up, and it will almost always be a multiple choice question, is reading the slope field. So this is going to ask what this slope field equation is possible. And for this, you really just need to look at it. And I mean, you can plug and chug, but you can also understand what's going on. So you know these are 0 values. So the 0 values happen when x and y are equal in value, which can kind of give you a pointer right away that it's x minus y and not x times y, because at those values, when they're greater, or if they were times, they wouldn't be 0. It would only be 0 at 0. So that crosses that out. And then x plus y, you know when they are equal, it would also be good. The only time it would be negative is when y would be negative. So that cancels that out and you're only left with a. Generally, what you're told to do is look at the corners. And I would look at the corners, but I would also look if you have any 0 values and large values. You're looking for these kind of slopes because those can give you a good idea of where the extremes are and pinpoint and be able to cross out. Okay, I hope you enjoyed this video. This was about slope fields and plugging and chugging with the differential equations.